Welcome to this week's MTD podcast. In this podcast, we will be discussing UK inventions and innovations. I'm Giovanni Albanese, hosting today's show, a passionate engineer and a very proud member of the MTD team. Today, I have the privilege to be joined by two special guests. Firstly, Steve Shikell, Sales and Marketing Director for LK Metrology. Steve's had a fantastic engineering career with over 30 years' experience, and we will be delving into that a little deeper shortly. Welcome, Steve.
Thank you very much, Gio. It's a pleasure to be on board today, and looking forward to your questions.
Brilliant, Steve. Now, we also have the privilege to be joined by the Swarf guru himself, Mr. Joe Reynolds, Managing Director of MTD CNC, with over 25 years' experience in manufacturing. Joe's speciality is cutting tools, and prior to joining MTD, he had his own cutting tool business. Joe's regarded by many as an entrepreneur within the industry. So, welcome, Joe.
Wow, bless you. Good job the camera's not turned on. Hi, guys. How are we doing?
Very well, thank you, Joe. Very well. So, guys, let's delve into your backgrounds. Steve, let's start with you. You know, why did you get into engineering? You know, what kind of companies have you worked for?
Yeah, so good question. At school, obviously, I was always curious about automotive and aerospace. Always seen myself as working in that type of industry. So when I left school, I applied to work for, it was British Aerospace at the time. They were more local to us than anywhere else. And I was fortunate to get a craft apprenticeship there. So basically, in my first year doing the craft apprenticeship work, I looked at various skill sets, and I kind of specialised in machining, which took me into the big machine shops. And if you've ever visited, which is now Airbus, you'll see some of their machine tools. They're like the size of 4 cricket pitches, so very big machines. And then after then, I kind of got involved in metrology. So precision manufacturing lends itself to metrology. So I spent quite a lot of time in precision gauge control. And then basically, I ended up in the tool room as a tool room machinist. And on the back of that then leaded itself to tool room inspection. And at the time, we used to do a lot of inspection of the aircraft wings. So they'd just innovated and brought a new measurement system back in its day using theodolite systems. So basically, you had 2 operators that were looking through telescopes, measuring a single point at a time, looking at the wing root interface. So I actually got involved in that project, and we helped reduce the measurement time from, I think it was about 8 hours, and I managed to get it down to 1 hour. And then in 2003, digital cameras first came out. So we then looked at moving away from using a manual operating, a telescope-based system, to using digital cameras. So I helped innovate and bring the first, in the UK actually, digital photogrammetry system in. So effectively, you just stuck targets on the wing and then took photographs of them and processed it with their software, which again we helped innovate and develop. And then moving on from there, we obviously then looked at improving how the aircraft wings were being built, because we could see obviously errors. So we then looked at a gaugeless tooling philosophy, and effectively we totally revolutionised how the aircraft were built by building them digitally as opposed to having master gauges and things. So and then that innovation led through to laser trackers. And then basically I left at Airbus to work for the company that was selling the metrology equipment. So that was about 2000. And then I effectively took that knowledge and passed it around all the other industries. So had great success in copying and pasting what I'd learned at Airbus and selling it to other aerospace companies. That then led through to working for Hexagon. And then I left Hexagon to work for basically a Slovakian company that specialised in process measurement. So we innovated using the laser trackers and laser scanners to inline measurement for scanning car bodies. And then last year I joined LK Metrology. And LK's got a wealth of history and industry firsts. So so far so good.
Steve, that's a fantastic background that you've got there. Steve, many innovations that we're going to touch upon shortly. Now, Joe, can you tell us a little bit about your background, please?
Yeah, so I did an apprenticeship with a cutting tool manufacturer called Galtone and Richard Lloyd, who people of a certain age will know. Yeah, he used to design taps, design milling cutters, end mills, different geometries. You'd be given components from companies such as Ford, Nissan, Airbus, Rolls-Royce, Honda. Yeah, and you'd have to design cutting tools around the drawing essentially. But in that, I went from like apprentice, obviously, so pretty much make a tap start to finish. Yeah, make a tap and milling cutter start to finish, whether it's indexable when you've got to look at how the pockets are made, the different angles, and all the rest of it. And I followed that through to on the road an application, a sales job. I ultimately left for a short period of time and went back as GM, reporting to the board. Well, yeah, it was good times, to be honest with you. Did a lot of machining, did a lot of grinding, both manual and CNC. So I had a short period of about 2 years out the industry as general manager for a big mold shop, automotive mold shop. And that, to be honest with you, that was a really good 2 years. Learned a lot about lean manufacturing, tack times, trying to take 2 seconds out of a cycle time was key when you're doing parts for Ford and, again, automotive where price is sensitive. Then I went back into the cutting tool world and ultimately I set up my own company, which was, it was doing okay, to be honest. It was more of a lifestyle change to join MTD rather than anything else. About, crikey, 10 years ago or more, maybe even more now. So, yeah, no, time moves on fast. Unfortunately, it's all I've ever done is manufacturing. I don't know if that's a good thing or a bad thing. But it's, love what we do at MTD. We're very fortunate. We see a lot of things earlier than a lot of people will. We see all the latest innovations. Quite often we'll come up with ideas and things. I guess we do the good bit, but we don't have to sell the tools anymore, do we, Gia?
No, I think that we're so privileged, to be working for MTD CNC. We get to see all the latest innovations and technologies that are brought into the marketplace. I've calculated or done rough calculations that between the three of us, we have over 80 years experience within the manufacturing and engineering industry from different kind of sectors within it, really, and different, I've been work holding and machine tools, you've been cutting tools, Steve Metrology, and between the three of us, we have seen many changes over the years. Now, innovation is absolutely essential for us all to evolve, for us to become more efficient, more profitable, more competitive. And I want to just kind of start with you, Steve. What's the best invention that you've seen so far? What is the best innovation that you've seen that's really been a game changer within the metrology sector?
Wow, it's a good question because there's been so many. If I go back to the days at Airbus, I think that was quite revolutionary in its day because if you look at how they used to build the jigs, really, to effectively build the aircraft components or the sub-assemblies, in the early days, they used to use static sites. So for Airbus Broughton, they had a facility down in Airbus Filton, which housed these static sites. And you can imagine if you've got a complete wing, but it's actually made out of a master model, and all the jigs would be built and set to that master model. So effectively, you had to maintain the master model. And then if there's any design changes, you'd then have to strip down the jig and take it back down to Filton and reset it to the design changes. And that was very costly, very expensive. And going back to what I said earlier, so, when we were measuring the wings, we could see trends where certain jigs, were slightly worse than others. So there was no two jigs the same. And my question was, well, why on earth aren't we using this technology to rebuild the jigs, to build them to their design intent? So rather than, because if you build a master static site, there's obviously going to be errors in that. And then if you build a jig to that, you're going to also induce errors in that. So there's a continuous stack up of errors. And if you look at the traditional instruments that they used to use, they were very manual. So you may have seen stick micrometers. So, if you've got a length of stick micrometers that are going over sort of 50 meters, there's a lot of uncertainty at the end of that. Or if you're using telescopes, again, that's down to the interpretation of the operator. So for me, when we started using the digital metrology systems to rebuild the jigs, that totally revolutionised how aircraft are built. So effectively, doing away with the cost of all of these big, expensive static sites and the buildings and obviously the maintenance of these, and just going back directly to the design intent. So if there's been any design changes, then ultimately it's just a digital electronic file that you import into the software. You go in with a measurement device, and then you can just start setting it, within days, or within hours, really. But as I say, that was such a big change. And what I would say it did is it actually reduced the lead time to production from taking 3 or 4 years to build a static site and then maybe a couple of years to build the jigs, down to you've designed the jig, you can actually then go and build it, and within 6 months you've got a working facility. And I think, looking at the innovations over the last, or the different variants of aircraft that have come out over the last sort of 20 years, that wouldn't have been possible if we hadn't have done that back in its day. So I would say in the 90s, that was really pioneering stuff and made such a difference.
That's an hard one to beat, Steve. That's a great example of innovation and inventions. Joe, what's the best innovation in cutting tools that you've seen over the years?
Probably nothing quite as exciting as that, I'll be honest with you. There's a number, to be honest with you. There's a number. A couple of the game changers was when carbide end mills, they went from traditional helix to unequal helix, variable helix. And what that enables you to do, that reduces all the harmonics when you're machining. And if we see some of these roughing cycles now, if you were to put an end mill on there that doesn't have an unequal helix, they wouldn't crikey, the spindles wouldn't last. It would be a lot more noisy. Tool life would be poor. So just when as soon as end mills in the late 90s, early noughties went to unequal helix, variable helix, that was certainly a game changer. There's when indexable tools went tangential, so obviously how the insert was changed. That for certain materials again was a game changer. In Galtona, we were doing that in the 90s, and it became probably industry standard for many sectors, probably 10 years after that, believe it or not. So that was a game changer for companies like Ford and various other companies making, certainly, cast iron. But if you look at most manufacturers now do offer many tangential systems, whether it's a high feed, whether it's a 90-degree platform, 45-degree face mill, a lot do offer tangential mounted inserts. As we move forward a bit closer to where we are now, these conical barrel mills, if used correctly, the savings, I know you know a bit about these, Gio, but the savings are staggering. 80-90% isn't unrealistic. In certain components, you can take a 4-hour. My maths isn't that great, but you can take a 4-hour cycle down to 20 minutes, for argument's sake. I've seen, and it is staggering. But on top of that, what you'll find is with a lot of cutting tools, there's always a weak link. It's either the software gets held up and there's no product development. Maybe the machine tool hasn't progressed for a number of years, or the cutting tools, where at the moment we do seem to be in an era where everything's progressing. Work holdings getting better by the day, tooling, coatings, metrology, machine tools. Some of these 5-axis machines we see now, sliding heads. It's all moving forward at probably the fastest pace I've known. People will say, how good can it get? And maybe it's slowing down, stagnating. I think the opposite, actually. When we start talking about AI programming and machine learning, only knows where that's going to be in 5-10 years time. So the growth curve will continue. Technology will continue to evolve, and it's up to people like Steve to do it.
I think.
Hey Joe, just wanted to interject there, Joe, because it brought back some memories when I was working at Airbus again, and I spent some time working in the machine shop, and we were bringing in ISCAR cutters, tip tools for the first time. And then I can remember going into the tool room, and the guys there with a fly cutter, and he could literally peel the swarf off as it was going around. It was that slow. And I kind of looked at them and I was like, hang on a minute, have you not seen this new technology, these tip tools? And then I went to the machine shop and brought some back into the tool room, and I think that everyone just looked frightened of it all because the amount of the material that we could remove so quickly, and the surface finish that we were getting, they were totally blown away. So But
Exactly. Yeah, you're
yeah.
right. And high feed technology. I didn't mention high feed, but the first time people saw high feed, they'd be scared. They'd be running away. They think the swarf's going to break the screens on the machine tools. It's the first time they saw high feed. But yeah, there's lots of technology advances over the years, cutting tools and software and machine tools. But yeah, where do you start, really?
I mean, you've made some really good points there, Joe, in regards to how everything is interlinked, whether that be the cutting tools, the work holding, the metrology software, tool holders, and without everything evolving at the same pace, you will always have that weakest link. So it's so important that everything does evolve, so everything else can work to its optimum performance. In regards to design, innovation, and new inventions, Steve, you were on the Dragon's Den not too long back with your own invention. Can you tell us about this?
Yes, yeah, sure. I mean, basically, I won't take all the credit for it. It was a good friend of mine who was actually a customer, and he came up with the original concept. And I'll tell you a little story, really, just to describe where the need came from. Basically, he was walking his dogs. I think he was on Barmouth Beach on a beautiful summer's day where the rain was horizontal and it's probably about 6 degrees. And the dogs had been obviously in the sea. They came in and he was trying to get the standard trigger clip lead to hook onto the dog's collar. And his hands were absolutely stone cold and he was struggling with dexterity on his fingers. So he was struggling away, and it just made him think there's got to be an easier way to do this. And so basically, over many months, he looked at various options and solutions and made various prototypes out of very crude sort of materials and things. And then when we started looking at magnetics and stuff like that, we realized that we could actually use magnets and clips to bring things together. So basically, I got involved to help him, promote it, market it, but also finalize and do a little bit of market research. So we got it to a stage where we actually got good coverage. We got a distributor to take it to market for us. I think it was in 13 countries. But the problem we had is that people didn't know about it, and it was a sort of product. If you saw it hanging on a shelf in a shop, you wouldn't actually know what it is. So it's not something that you can relate to because it was brand new and it was obviously pioneering stuff. So I just said, look, let's just get it on Dragon's Den. It's the best way because it's going to get coverage instantly overnight. So we applied, and sure enough, we got to go on it, and it was quite a surreal experience because obviously without giving too much away, but when you're in there, it's obviously a set, so it's not an old building. It was actually a brand new building, but inside it was made to look old. And
there's no lift, I bet. No lift at all.
Yeah, exactly. So basically, there's a guy there. When you press the button, he's there flicking the switch to change the numbers on the lift to show that it's moving from one floor to the next. But yeah, so when you actually go in, from that moment on, that it's all filmed, that it's all real. You don't get to meet anybody beforehand, and it's a grilling. It really is a grilling. And we were probably in there for a good hour, and
really.
Yeah, but obviously when you see it on TV, you only see 10 minutes. And but we were successful. We got investment. So we got investment from Nick Jenkins. And it's been good. I mean, obviously the product's still going. It's still a live business. But I'm more of a shareholder now, so I'll let Tony run with it now. But many innovations have come out of it from there. And the more recent one is a product we call Solock. So basically, using the same innovation where you basically point one thing to another and it automatically connects and locks in place, and we've put that into a lap belt for wheelchair users. So basically, those who've got less dexterity and obviously movement of the hands and things, so people who have perhaps got some disability, and it's important that they're restrained in a wheelchair so they don't fall out. So basically, we've come up with a new product called Solock. So you can use it with one hand. So the whole idea is just that somebody who's only got one hand can actually buckle themselves up, and so that's been well received. It's currently under trial with the NHS. we've got lots of people interested in it, and even for stair lifts as well. So again, people going up and down in stair lifts don't generally buckle themselves up, but they should do, because obviously they could lean out and fall down the stairs. So. And yeah, we've looked at the statistics, and unfortunately, if you look at the stats, there's unfortunately a lot of people who obviously have a fall in their home, and then they become critically ill from that fall. And there's quite a few people that unfortunately do lose their lives on it. So we do see it as an essential thing. But more importantly, what's been really good from the innovation side is using the modern techniques from engineering, rapid prototyping, using additive manufacturing to print parts, to prove the concepts, laser cutting to make parts without having to get tools made and stuff like that. So it fits really well. So it's a nice hobby to be involved in, and it really complements what we do on a day-to-day basis. So
brilliant.
So what's the what the website, Steve? I'll give it a little plug.
Yeah, sure. Yeah, so the Maglock one is www.maglock, so magloc.co.uk, and the other website is www.soloc, so SOLOC.org.
Brilliant stuff, Steve. Now, you've obviously progressed significantly, from the Dragon's Den to the MTD podcast.
There you go. I'm living the dream today.
And I think it's another great example of one innovation leading to another.
Absolutely.
Your first invention led to the latest one through creating something that's not been created before. It opened your eyes to other avenues in which that product line could go. Now, Steve, just want to touch upon your current role now, working for LK Metrology. They've got a strong heritage, especially when it comes to innovation and design. Now, back in the day, I believe in 1963, two pioneers, Norman Key and his father-in-law, Jim Lowther, set up LK Metrology, and they were the first pioneers of the bridge type CMM. Can you tell us, and amongst many more, I work closely with Rolls-Royce, can you tell us a little bit about their story and about LK, the company that you're currently working for now?
Yeah, absolutely. Yeah, so as you quite rightly say, it was set up by Norman Key and his father-in-law Jim Lowther, and basically Norman was a Rolls-Royce engineer. And he set up this company to effectively, it was like tooling company, so it was making tools and granite beds and tables. But they also worked with Sir David McMurtry from Renishaw to help him develop the first touch trigger probe. So I believe he offered them some shares in Renishaw at the time, and I think they thought that they had a bigger organisation, and they kind of declined. But maybe in hindsight, that wouldn't have been such a bad idea. But yeah, so looking at many of the first that they did, so they designed and developed the first bridge type CMM. So effectively, that is a standard today. I mean, there must be over 100,000 CMMs in the world now that are using that same technology. And then also they've developed lots of other things that we don't necessarily know about. They actually worked a lot with Boeing, some of the military bases in America for developing. When you start using composites, there's NDT machines that need to be created to look at delamination and stuff like that. So they worked on some of these big V bombers, developing some unique bespoke machines for that. But again, we don't really publicise all of that. But there's been many firsts from that perspective. And then moving on from there, they've obviously designed and developed using different technologies. So initially, the first CMMs were quite heavy and very sturdy, very solid, because it wasn't just a granite bed. They were using granite, the bridge construction as well, which very stable, very accurate, but it's quite a heavy mass. So you can appreciate the machines today are a lot faster in comparison because we're using lighter materials. So through the time, LK looked at using composites. So they made a composite bridge and a composite spindle. But they were finding that the durability wasn't as good as they'd expect. So they then went to move on into ceramics. So the beauty with ceramic is that you've got the same characteristics that what you get out of granite, but you've got probably only 5% of the weight. So we've got a very thermally stable machine, which is mechanically accurate, but also we can use it in more harsh environments because of the stability of the materials that we use. So it's not so susceptible to temperature change. Different probing technologies. We were part of Nikon for some time, so we developed a lot of laser scanning technology to go on the end of the quill to help speed up measurement processes. And then we developed in-process CMMs for car bodies, so body in white construction. So again, in America, they did many firsts there with General Motors and Ford. And of course, we're still innovating today. We've just launched a range of portable measurement arms, and we've still got our own software suite that we're developing on a day-to-day basis. But we're moving more now into the Industry 4 sector. So we're trying to focus on what you do with the data. And if you're a quality manager or a production manager and you've got our machines in process, it's been able to manage those from a mobile phone and an app so that you can have a holistic approach or holistic view of your production facility. And instantly, if there's a problem, you get it pinged to your mobile phone in an app. So it's we're kind of evolving and making it more easy to use and more visible,
Absolutely brilliant. I mean, Steve and Joe, when we have conversations such as this, it really fascinates me to think that we have problems getting people into engineering and that we've got a skills shortage. It really, really baffles me. I really can't understand it. I mean, there isn't, in my opinion, anything better than designing something from scratch. What do you think, Joe? I mean, with MTD, you set it up with, and you were part of MTD from the very start. And it is educational, Joe. It really opens the eyes. We're quite privileged in regards to being able to see the industry from a bird's eye view, something that I didn't really have that luxury to do before, albeit I was still fortunate to be on the road and visit many companies. However, working for MTD, it really opens everything up. We're so privileged and we can pass that knowledge and information on to our audience. But Joe, in your opinion, from the conversations that we've had, how important is education and why are young people or not enough young people getting into this fantastic industry?
Well, it's a good question, mate, and it's a difficult one to answer. But all I can say is, how often do you see it in the mainstream media? Of course, if you're loosely involved in manufacturing, hopefully you're aware of our channels and Paul, the founder, he set it up for a number of reasons. Obviously, education is a big part of it, but also helping people sell kit, essentially, metrology, work holding, cutting tools, machine tools, promoting a product, which hopefully, ends up culminating in an inquiry and order. But in terms of to answer your question about why don't people join, I think it's when you see the BBC, and I'm not here throwing accusations, but when you see the mainstream media talking about manufacturing, it's either some unrealistic shot of JLR's production line when it's all robots and no humans, or to the other end of the spectrum, it's Sheffield Forge Masters, and you've got these big ladles of molten material. And to be frank, fair play to them, that's not necessarily somewhere I would want to work. So they don't show the good bits. They don't show you the nice, clean machine shops. The average machine shop now is clean. Okay, you still have to do an element of manual work, but these machine tools, it's like running an iPad. And I think if these, and kids aren't kids anymore when they leave school, they pretty much leave school as adults, but it's these young adults, if they knew what was on the horizon, the fact the average salary is £32,000 against 26.5, I believe, is national average across the board, across all industry. If people knew that, I think it would attract more people. But it's, we're doing our bit, but more people need to do more, is what I think.
Yeah, I'd like to interject there. I think, Joe, just to say, I think it's got to start at the schools, really, isn't it? Because, it's all very well having all the things that we normally do, English, maths and history and science and stuff, but it really has got to get into the curriculum, to get engineering and manufacturing concepts brought back into school, because, it's one of those things. You're either more biased to using your hands or you are more academic, but I think it's a string of both today. I mean, you've got to be extremely academic to work in engineering today, certainly understanding all the engineering principles. But it really must start at school. And, again, things that kind of inspired me as a child. I can remember when the first space shuttle went up, being all brought into a classroom and watching this TV, seeing the first shuttle launch. And, that kind of just inspires you a little bit to get involved. And then, at home, you'd always be doing things like, whether it was Lego or Meccano sets or, fixing your bicycle, you're very hands-on. And I think today you just don't see that anymore. I think most children generally sit behind the phone or the PlayStation or Xbox. And I think there's certainly a missing there. And it's just to create that inspiration to get them involved.
I think, Steve, that's a really good point. And I think that, going on what you said, actually, I've got two children, one's 3.5 and one's 5.5. They're so into their Lego, they're so into their trains, they're so into all of the stuff that, typical little boys, or myself included, love to play with. I believe, and I could be totally wrong, that something happens to these children during school. They stop playing with their Lego and and the thing is, once it's gone, it's gone. I think that maybe they need to be, I don't know. They need, it's such a fantastic industry. It's at the forefront of all technology, and that intuitiveness and that kind of entrepreneurialness is available in engineering and in the manufacturing industry. There's so many routes to so many jobs within this industry, and it's an awesome industry to be involved with. Guys, it's been an absolute pleasure to have you guys on board today. Any last thoughts?
I think from my side, I just think it's all about education, as you say, and the job that you guys are doing is fantastic. It's helping get out there in the main sort of domain. I'd just like to say thank you for giving me the opportunity to support you on this podcast today. So
thank you, Steve.
And I wish you all well and stay safe.
Thanks, Steve. Joe?
Yeah, thanks, Steve. I'm off up to set. I'm just saying to Steve, I'm off to set up my new business, which is called MTD for Dogs. Good shout, Joe. Well, thank you, guys. It's been an absolute pleasure. If you've been listening to this MTD podcast and you have any questions that you'd like to be answered from Joe or Steve or even myself, please just send your inquiries and questions in to MTD Inquiries. Make sure to subscribe to the MTD podcast on your iPhones. Until next week, it's the MTD podcast. Thank you.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.